In this video, we will be taking a look at VSEPR theory, and we will be using this theory to determine and compare the shapes of different molecules. Before watching this video, it is important that you understand how to draw Lewis diagrams. So if you still do not know how to draw these diagrams, please be sure to watch the video on Lewis diagrams. Before jumping into a problem, I would like to remind you of the theory booklet that you can download. In the theory booklet, you will find the table displayed on the screen. These tables show the general formulas and the shapes of molecules that you need to learn off by heart. On the left-hand side, we have the ideal shapes, and on the right-hand side, we have the non-ideal shapes, which molecules have when they have lone pairs on their central atoms. In order to determine the shape of a molecule, we start off by drawing its Lewis diagram. We then determine or complete the general formula, and we can then use the general formula to determine the molecular shape. Our first problem says, use VSEPR theory, also known as valence shell electron pair repulsion theory, to compare the shape of the water molecule to that of the HCN molecule, also known as hydrogen cyanide. We start off by drawing the Lewis diagram for H2O. We notice that on the central atom, which in this case is oxygen, there are two lone pairs. There is two terminal atoms in the water molecule. And using this information, we can complete the general formula, which becomes AX2E2. And this tells us that the water molecule has an angular or bent shape. To determine the molecular shape of hydrogen cyanide, we also draw its Lewis diagram. Notice that between the carbon atom and the nitrogen atom, there are 3 bonds. It contains a triple bond. On the central atom, carbon, we have no lone pairs. It is only surrounded by bond pairs. But the hydrogen cyanide molecule does have 2 terminal atoms. So when we complete the general formula, we find that it is AX2, which means that the shape of this molecule is linear. We can now answer this question in words. We say, both the water molecule and the hydrogen cyanide molecule have 1 central atom and 2 terminal atoms. However, the hydrogen cyanide molecule has no lone pairs on its central atom, while the water molecule has 2. It is because of this that the hydrogen cyanide molecule is linear, while the water molecule is angular, and you can also refer to it as bent. If you would like to elaborate further, you can also point out that the water molecule, since it has a lone pair, or at least 2 lone pairs on its central atom, these lone pairs repel each other, and the bond pairs more than the bond pairs repel each other. And it is for this reason that the water molecule is angular rather than linear. We are done with this problem, and we can hop into the next one. The next problem says, use VSEPR theory to determine, or rather to compare, the shape of BF3, boron trifluoride, to that of NH3, the ammonia molecule. We again start off by writing down or drawing the Lewis diagram or Lewis structure for boron trifluoride. In this case, boron is the central atom, and it has no lone pairs on it. But the boron trifluoride does have 3 terminal atoms. Now, sometimes lone pairs can be a bit confusing. You might notice that there are lone pairs on the fluorine atoms. But, junior techies, it's very important that you understand that the fluorine atoms here are terminal atoms. So we say there are 0 lone pairs specifically on the central atom, which is boron. Boron only has bond pairs around it. So the general formula, the completed general formula for this molecule is AX3, which means that its shape is trigonal planar. We now draw the Lewis diagram for ammonia. We find that on the nitrogen atom, which is the central atom in this molecule, there is one lone pair. The ammonia molecule contains 3 terminal atoms. So the general formula becomes AX3E. This means that its shape is trigonal pyramidal. We can now answer this problem. We explain our answer in words. We say, both molecules have one central atom and 3 terminal atoms. This is what is similar about the molecules because we are comparing them. However, BF3 has no lone pairs on its central atom, while ammonia has one. BF3 is therefore trigonal planar, while ammonia is trigonal pyramidal. And again, if you would like to elaborate a bit further, you can say that the ammonia molecule has a lone pair on its central atom, and that this lone pair repels the bond pairs more than the bond pairs repel each other, and it is for this reason that it takes a trigonal pyramidal shape instead of being trigonal planar. We've completed the second problem, and we can now go on to the last problem of this video. It says, determine the molecular shape of H3O+. This is the hydronium ion. If you have watched my other videos, you would know that there's one video where I explain and complete a problem involving a dative covalent bond. So what I have written on the screen should be very familiar to you, and you should know that on the right, we have the Lewis diagram for H3O+, the hydronium molecule. We can now analyze its Lewis diagram, and when we do so, we find that it has one lone pair and it has 3 terminal atoms. So the general formula, the completed general formula for this molecule is AX3E, which means that its shape, its molecular shape, is trigonal pyramidal. Ladies and gentlemen, we have completed this video and the problems contained in it. In the next video, we will be looking at the polarity of different molecules, which is an area that a lot of learners struggle with. Make sure that you understand all of the concepts that I have explained so far, that we've gone through so far, so that you can master everything in the next video. I wish you all the best, and I look forward to seeing you in the video to follow.